this is Dan Jeffries. I'm the Chief Technical Evangelist with Pachyderm and also the Managing Director of the AI Infrastructure Alliance. And we're going to talk about unstructured data, one of my favorite topics, and why it is the unsung hero of machine learning. When you think of machine learning's biggest breakthroughs in the last decade, what comes to mind? Maybe it's AlexNet dominating ImageNet in 2012 and unleashing the deep learning era. Maybe it's self-driving cars navigating the complex chaotic streets of a big city. Maybe it's these new massive transformer language models with trillions of parameters, the scanners recognizing your face, GANs generating photorealistic people, Open AI DALL-E 2, which is just incredible, generating photorealistic images from text, and then Google following with Imagen, or a bot even recognizing what you said. What do all these things have in common? The most obvious answer, because you're at an unstructured data conference, is they're all built on the back of unstructured data. And unstructured data is the unsung hero of machine learning, and we're going to talk about why. What is unstructured data? Think of video, audio, images, and big chunks of text. It's anything that doesn't neatly fit into a database or a spreadsheet in neat rows and columns, and anything that is going to be like completely sort of different from those types of things. And structured data and hand-coded logic powered the rise of the web. Those are a coder basically thinking of all the logic that needs to happen, putting it together, right? So if I'm writing a login script to a website, the data is secondary. I maybe only touch the data once or twice. I write all the logic for the login, and I touch the password and username hash in order to get in order to log into the website. But with machine learning, the data is primary, right? The machine learning model is going to learn everything that it needs to learn from the data itself. And unstructured data in particular is powering the next generation of webs, apps, and beyond. And the most interesting thing about it is that 80% of the data in enterprises is unstructured. And yet 80% of the MLOps tools are built to handle only structured data. And why is that? Well, it's because it's easier. We've been dealing with structured data for a long time. We know how to fetch things from a database. We know how to pull usernames and passwords, or pull, people's age and name and social security number. We know how to pull these things from a database and write it into code. Unstructured data is hard to deal with. It's hard to deal with from the standpoint of where we store it, of how we process it, how we interact with it. There's no schema around it. Like, you have a very structured schema when you're looking at a database. And so we actually need a bunch of tools that are built from the ground up to deal with it. In addition to that, when you start to really look at where most people are spending their time, when you're in academia and machine learning, you spend a lot of time clicking once, downloading the perfect data set, and then spending all of your time kind of in experimentation and trying to make the perfect model. And that's completely reversed when you get into the real world and you're pulling data from 3 or 4 different databases and maybe grabbing something from an email, pulling something else from Kafka, pulling something else from a data lake, and then you're trying to merge it all together. There's conflicting fields, right? There's different things that are broken. There's white space, there's images that are at different sizes, there's videos in different formats. We spend all of this time in the data engineering side in the real world. And this is where a lot of these tools are. And the problem is, of course, this unstructured data. We're talking about video and audio, genetics data. It doesn't fit easily into a database, no matter what some clever marketing departments want you to believe. Right? You're not going to take a 1 gigabyte video file and shove it into a database and hope that it actually works, and then make 20 copies of it. So it needs to live in a completely different kind of format in order for us to be able to deal with it as data engineers. And that's what we're going to talk about today. We're going to talk about you need a tool designed to deal with the unstructured data. We're going to talk about Pachyderm, company that I work at, and why it's designed for data engineers from the ground up to deal with these things. It's a data-centric pipeline, right? And data-centric is a bit of a buzzword today, but I'm going to talk about it from a very practical standpoint. How do we deal with it in the real world, okay? And we're going to talk about the key features that you need to be dealing with this data for where you're spending 60, 70, 80% of your time. It's not in, experimenting, right? It's not in building models, it's wrangling that data, getting it in there. So the first thing you need is you've got to be able to deal with that data in its native, natural format. Okay, you don't want to have a bunch of wrappers and boilerplate code and an unnatural schema that you're trying to jam it into that doesn't make any sense. And this is why you want to have essentially a data lake, right? And most of the platforms have this completely backwards as they try to just shove that square peg into a round hole and store it unstructured data. This has been kind of a losing proposition since the 1980s of trying to shove documents and PDFs and everything else into images, everything else into a database. It doesn't work, and so you really need it in its native format. And Pachyderm is a data lake with some special characteristics. It has a Pachyderm file system that sits over the top of a data lake, like an S3 or an Azure Blob Store or Google Blob Store, and it's able to do all kinds of things like deduplication and the other types of things that you really need. The other thing is you want to use the DB right, and so we're going to in Pachyderm we're only using the DB for what it is good for and nothing else. So Pachyderm uses this hybrid approach. We're storing the data in this copy on write style file system, the Pachyderm file system, which does deduplication and takes snapshots every time automatically as you're making changes to it. You don't have to call it, you don't have to remember to call it, or more often than not, forget to call it in your code and then you can't go back. It's automatically versioning it and only keeping pointers to the changed bits. Okay, so that's incredibly important. If you've got a bunch of video files in there or gigantic images, and each one's a gigabyte, and you're making changes to 2 or 3 different scenes in there, and that's only adding up to a megabyte or 2, you don't want to be using these systems where they're basically making an entire copy of that 1 gigabyte file. That's an exponential growth. You want it to be able to just copy the changes and then keep those changes in a database, in our backend database, which is using distributed Postgres in the back. It keeps all of the changes that you're making in there, all the lineage, all the versioning snapshots, so you can roll backwards and forwards at any point in time. So DBAs are fantastic at super fast lookups, storing metadata, and they absolutely stink at storing unstructured files. So you want to be able to go ahead and put them use the DBs for exactly what they are good for and nothing else. The next thing you want a platform to be able to do is incremental change processing, okay? Incrementality, it's a weird word. What does it mean? It means unstructured data can easily get very, very big. Millions of images, large videos, genomic sequences, all kinds of text documents for these NLP models. You want to process only the data as it comes in. Right? If you've got 2 petabytes of data, you've already processed it, you don't want to process it again. So if you got something streaming in from Kafka, if you've got something from, a bunch of new databases that are coming in, if you've got another data lake that you're pulling a bunch of things from, you only want to deal with the new data that's coming in. Pachyderm is able to do that because of its versioning and lineage. It's able to keep track of all the data you've already processed and where your model already is with the checkpoint, only process the latest thing. That's incredibly important. And you want it to be able to trigger a new pipeline and an automatic rerunning of that pipeline, right? And that's what Pachyderm is able to do. A new piece of data comes in and you can set it to automatically process that or set it to process after 100 new images or 1,000 new images have come in or every time a new image comes in. And that's what you want to do, but you still only want to process the new things that are coming. You're in charge with how you do that. The next thing you need is massive, massive scalability. So Pachyderm, runs on Kubernetes and it auto scales up your code with containers. A lot of the other platforms out there, especially these platforms that require you to build like a DAG, right, with like Airflow, where you pre-bake the entire DAG, right, or something like Prefect, where you're using Dask to scale it. You don't need any of these additional things. Pachyderm will automatically scale your code. Okay, so if you write code to go process, a bunch of those images and take them from 1024 by 768 and crunch them down, or change an MP3 to a WAV file, or do something to do a filter on a bunch of videos so they can get better contrast in there, you can just write that code and it's going to automatically slice up the data as it comes in. And we've seen this a ton of customers, right? We saw this, I think, with Logmein that was doing like audio processing. And they were trying to shove that audio that they were basically doing transcripts of into these giant containers, the biggest containers they could get them into. And it was just ridiculously sluggish. It was taking like 7 weeks to process these chunks of audio that were coming in from their call centers with Pachyderm. They didn't change a single line of their code. And it sliced up the data into smaller parts and processed it at the same time, okay? So all of a sudden they went from 7 weeks to 7 hours to process this data. And that's because it's basically spinning up a whole bunch of containers, spinning up a bunch of pods, running the same code and chunking that data out. So when you're dealing with big video files, images, genomics, millions of images, you've got to be able to process it in parallel. And you don't want to have to write a bunch of boilerplate code or spin up another library to make this a reality. Customers are often seeing a 10x speed up when they're doing this crazy data processing, these complex data transformations. They're pulling things in from 5 different places, they're merging it, they're changing it, they're flipping it around. These complex transformations, you see these tremendous speed ups when you're trying to process this data, and you're dealing with it in its native format, no boilerplate code, no additional code, no rewrites. You just think about the code, you write it, you're able to do it. The other thing you need is data versioning. Now, there's a lot of companies and platforms out there offering some modicum of data versioning, but it is not the same thing. In other words, most of them are missing very important features. And the number one feature that they are missing is ironclad immutability. That means you have to have a complete copy of the data that can never be changed every time you're taking a snapshot. This is why you can't use something like Git to do your data versioning. Git it works for code and it works for sort of smaller sets of files. But if you're just doing pointers to files, but they can change out from under you, you can easily get into a problem where you've only got an incorrect state of data referred to in your database, okay? So a state that doesn't exist. Let me give you a perfect example. Let's say you've got a million images in a directory and they're 1024 by 768. You run a bunch of experiments, 50 different experiments, and then some administrator comes along, okay, and crunches those 1024 by 768 down to 512 by 512, overwrites them. Now all those 50 experiments you simply cannot recreate them because the database refers to a state of the data that no longer exists because you don't have immutability, okay? If you don't have immutability, you absolutely do not have data versioning. The other thing you need in there is you've got to be able to have deduplication. We talked about this earlier. If you're not able to keep smaller versions of just the change data, your file system can easily balloon. The other thing you absolutely need is it's got to happen automatically. I've seen things like this, such as with Kubeflow, where you've got to remember to call a snapshot along the way. If you've got to remember to call a snapshot in code, you're writing a lot of repetitive code for no reason. And you're going to forget to do it right when you need it. It's just like those old days in the backups in IT. If you don't script it and make sure that it happens on a schedule and check it, then it's going to fail right when you need it to not fail. So you need this to happen automatically. Pachyderm is constantly taking snapshots every time a change is made, and it's keeping the interrelationship of the data, the models, and the code, and how all those things intersect at any given point in time. And another reason you simply can't use Git to do this is the paradigm doesn't work. In other words, with Git, you're always syncing all that code down to the individual coder's laptop. That's not going to work with 50, 60, 70, 100 terabytes of data. You're not even going to be able to sync it down to your laptop. So you've got to be able to point to like a centralized location. And so you can only take inspiration from Git, right? And that's what Pachyderm does. It centralizes it in a data lake, so you have that ironclad immutability, right? It's not synchronizing 2 petabytes down to a laptop, which is impossible. You simply can't do it. You've got to be able to have it centralized. So you need a versioning data lake. And this is incredibly important when you're dealing with unstructured data. The last thing is that lineage. We talked about that. Every version of your data, your code, and those relationships has got to be taken automatically, and that's got to go into its proper place, into the database. A lot of people call that a metadata database or whatever. For us, metadata is tightly coupled with our pipelines and scaling and everything else. It's not an external database that can't maintain that immutability, that can't take the snapshots, that can't recreate your pipelines. That's the problem with some of these external metadata systems when they're basically just looking in on other systems, but they can't really act as the puppet master of those systems and enforce that kind of immutability and the things that you need in order to be able to track that lineage. That's how you maintain your compliance and reproducibility. This is going to become an incredible problem for people down the line, even if they can't see it coming. when 2, 3, 4 months later, people are coming and saying, where did you get that data? How did you build that model? In the future, it's probably going to be an auditor or a regulator. If you're in a highly regulated industry like a bank, or there's life and death involved, or human safety, you're absolutely going to need to be able to do it, but it's coming for everybody, tech companies, everything else. So you have to know where your data came from, how it got there, how it changed. And you have to be able to reproduce your models at every step. And lineage is not a short-lived thing. So you see stuff like this with Databricks, where lineage, they talk about having lineage, but it by default lasts for only 7 days. Okay, so you don't want that. You don't want it to be tombstoned after 30 days, because that's just looking at it from a pure experimentation standpoint. But in reality, you need to be able to go back many months or even half a year or whatever to look at a model, where the data came from. If you're facing a compliance or an audit, you need to be able to go back there and look at those things. And sometimes you might realize there's an anomaly in your model down the line, or it's having a whole bunch of hidden inference problems that your observability platforms and your explainability platforms start to suss out. Maybe it's a challenging problem that you miss. You need to go back and look at that data and that code, understand where that problem came from many months down the line. So data lineage is a long-lived thing. It is not temporary. You don't want to be deleting all that lineage later. You want something that can scale it and keep that over time. So that's it. We've talked about the kinds of platforms that you really need in order to do strong data engineering, data-centric pipelines, unstructured data, dealing with those videos, those audios, those genetic sequences. You need a different kind of tool. 80% of the tools that are out there are basically designed to do experiment tracking and all those other things, when 80% of our time is spent dealing with wrangling that data, and especially true when you're talking about all this unstructured data and putting it together in a comprehensive fashion to process with your model. So I'm Dan Jeffries. I'm Chief Technical Evangelist for Pachyderm, Managing Director of the AI Infrastructure Alliance, which is a gigantic alliance of 40 plus companies, including our beloved Arize, all coming together, working on standards and interoperability and generating content for everybody. So go and make sure you check that out at https AI-infrastructure.org. That's https://ai-infrastructure.org. You can also find me on Twitter and LinkedIn. Thanks so much for your time.